Hello, everyone. I'm Ella Johnson. I'm a principal architect leading the Polaris Industry Solutions at Snowflake. I also have Venkatesh Sekar joining me, and he's also a principal architect developing industry solutions at Snowflake. In this demo, we're going to go over a collaborative logistics solution we built in Snowflake, leveraging Carto's advanced geospatial capabilities natively running in Snowflake. Let's start with the use case definition and an overview of the solution. When looking at retail logistic challenges, we are seeing a few key themes. First of all, after the pandemic, online shopping has increased drastically, and as a result of this, retail organizations need to use more intelligent techniques to optimize their logistics around customer deliveries. Secondly, the well-known last-mile problem, which comprises around 53% of overall cost of shipping, still becomes a huge problem for retail organizations. Last but not least, increasing e-commerce deliveries worsen traffic conditions in fast-growing cities, and this essentially requires smart city initiatives to take place. Let's look at a real-world example now, covering the collaborative logistics use case. My home city, Austin, Texas, is rapidly emerging as one of the dynamic growth cities in the U.S. Known for its vibrant culture and thriving tech scene, Austin is drawing both businesses and residents at an unprecedented pace. As per U.S. Census Bureau data, Austin population has surged by nearly 22% over the past decade, making it one of the fast-growing U.S. cities. This is all great, but this example of urban growth comes with a cost for Austinites like myself. Austin has pretty bad traffic congestion problem trying to keep up with growing population, which requires smart city initiatives and responsible measures for many local businesses. One of the solutions to help with this is the collaborative logistics solution we built with Snowflake and Carto. With this solution, first of all, we share data across multiple retailers without sharing any PII or addresses using Snowflake data cleanrooms. Once we share the data, we also consolidate these deliveries within a certain proximity, and we chose more like 5 miles, across multiple retailers, and essentially consolidating these deliveries help with the last mile delivery costs for individual retail organizations. Last but not least, we're using cutting-edge algorithms, in this case, Carto's vehicle route planning service, to essentially recommend optimized delivery vehicle routes for our delivery vehicles within a city limits of Austin, and also giving them more information about near real-time traffic incident data within the city to reduce congestion and help improve air quality. So for our solution, as I mentioned before, we decided to use Carto, which is a cloud-native location intelligence platform to use advanced geospatial capabilities and visualizations natively running in Snowflake. Before we delve into the solution architecture and technical deep dive, let's highlight some key Snowflake and Carto features that power our solution. Starting with Snowpark Python, we use Snowpark Python that is powered by Snowflake's superior compute, leveraging Python stored procedures, UDFs, and the brand new direct external access private preview feature to make calls to City of Austin's real-time accident API service to retrieve accidents that happen within 10-minute latency in the city. Using Snowflake geospatial functions like SD within, we query all deliveries within 5-mile proximity from one retail's list of deliveries to the others. Moving with the Carto features, we leveraged Carto Analytics Toolbox, complemented our implementation with their advanced geospatial functions like SD cluster k-means and SD concave hull, and we're going to show you how we use these functions in a minute. Also, Carto Analytics Toolbox is now a native app in our marketplace. We also leveraged Carto's spatial indexes, even though our data set was not too big, but this really helped us with our implementation. Moving on, we also, as I mentioned before, leveraged Snowflake data cleanrooms to essentially share data between different local retailers without sharing any PII. And we leverage the brand new Snowpark Container Services now in private preview, which is a fully managed container platform, easy to use, just like any other Snowflake feature. And thanks to Snowpark Container Services, we were able to run Carto's vehicle route planning service natively in Snowflake, purely using Snowpark Container Services. Carto's vehicle route planning service essentially combines OSRM, OR tools, and their proprietary IP to calculate routes within the city limits of Austin, in our case, to essentially recommend optimized routes for our drivers. Leaving the best for last, Carto's superior map visualization with SQL was a key feature in our solution, where we run the Carto UI natively in Snowpark Container Services as well. With that, I'm going to turn it over to Venkat for a technical deep dive.
So in this demo, we are going to demonstrate a partnered last mile delivery problem. The business context is that two different organizations, sister organizations, one should deliver their goods to various customers, but use the common set of fleets and the vehicles, thus saving cost. So as part of this demo, we want to highlight how you can do this natively using Snowflake. Some of the features that we will be using in this demo is how to use data clean room, the adoption of geospatial functionalities provided by Carto as well as from Snowflake. We'll also have an external API access to get the traffic incidents of Austin, and a Carto with the VRP Snowpark Container Services itself. We log into Carto. For the target location, we are taking two store locations in the city of Austin. These two are two different warehouses which belongs to the same organization, but they are sister organization. They have to deliver products, their goods, throughout Austin, which is where all their customer base are. So if you look at that, what they found is that sometimes the delivery between customers are very close to each other. So instead of having two different trucks from each of these organizations go to these various their own corresponding customers, they wanted to see how they can optimize the fleet operation in such a way that they could share their vehicles and the workers and also save cost and time effectively. The organization has also decided that anything within these shaded location, which is the core of Austin, they do not want to share. They want to target the delivery location mainly in the suburbs of Austin or outskirts of Austin, like these places at these locations. One of the things that comes to the mind is that how can these two different organizations start sharing the data without informing each other about the customer? One way to do this is to adopt a data clean room strategy. In the data clean room strategy, these two organizations can share their delivery location and they can find out the proximity of closeness of their delivery location using geospatial functions. So let's take an example of the flow. So here are the orders from two of these two organizations. They're cross-joined together and then they are found out whether each of these locations are within a proximity range. The proximity range for our discussion is 5-mile radius. So if they are, then they will be chosen as the delivery location and they will be stored in the results for further downstream processing. Let's take a look at the query of how this can be done. So here is the base query, which is CTE based. So we select the records from the party 1 order table, from the party 2 order tables effectively, and also the non-delivery location, which is in this case is this green sector over here is the non-delivery location. We use a std function to within function to define whether it is within a given proximity. That is, given two orders, delivery location, if they are within a 5-mile radius is the choice. So we are using it within proximity index. We also want to ensure that the chosen location is not within the non-delivery location. So we use this st_contains function. So with this, the results are now processed, and we are storing, we can find that the output of the results is roughly around 50% of each. With that, the data is now stored in a table. Because these are widely spread out, what we want to achieve is to have a clustering done. So this is the set of identified location. We want to now start forming a cluster. So for this, because there are different sectors and different locations, we want to form out clusters. So for this, we use the Carto's clusters k-mean function to achieve this functionality. We also, once this is done, we also want to form borders within these clusters. To form the borders within the cluster, like these outer lines, we use the st_concave hull functionality provided from Carto to achieve that. And that's, we have 5 clusters over here. With this in place, the next one is to solve for a vehicle route optimization problem. We also need to consider the ever-growing traffic needs. So we use an external function API provided from the Austin government website, which provides us data in real-time accident inserts. We use external APIs to get that data and store natively in Snowflake. So here is a function that we used, that we have defined, which will get these data out and store them in a table, in an Austin traffic table. Once this is defined, we can now visualize traffic incidents. With this in place, we have all the necessary information to determine what is needed. Now we need to plan out for the route optimization to start delivering to these places. For the next step, we are using the Snowpark services. We log into Carto. We find where the Snowpark container is running. So we log into the Snow services, and we choose the database where our solution is hosted over here. In the interest of time, this incident was already loaded up and we have already processed it. So this is we chose a specific cluster, and we want to target the delivery from the warehouse all the way up to this location. So based on a previous run, so the routes were determined, and we are looking at the route that was determined. Now remember that this is running natively in Snowflake using Snowpark container services. So thus the routes are determined, and this is what's displayed in the Carto UI. But from a processing perspective, this table and the sequence are also written out, which is then mapped out as what you see over here. With that, thank you for attending this session.